And so here's something else that happens with this, with each of these trophic levels. You have to have a lot more producers. You got to have a lot more things at the bottom level than you have in the level above it, right? Because this is the flow of energy. And at each level, the living organism is using the energy. It's not just a matter of, oh, all the energy I eat is enclosed in my body that's going to be consumed by something that eats me. That isn't right, because you're using the energy. You're using the energy to just digest the food, to generate warmth if you're a warm-blooded animal. You're using the energy to make new cells, to repair damaged tissue, or just to sustain life, or to grow if you're a growing organism, like, a seedling growing into a mighty oak or something like that, or a kid growing into an adult. There's a lot of different uses that you were using to move around, right? Our nervous system to shoot. It takes a lot of energy to fire those nerves. And so living organisms aren't just composed of the energy that they consumed or produced if they're a producer. They're using it. So there's never as much energy to go to the next level as there is in the level you're at. And there's always got to have to be more energy at the level beneath because it's being used up, right? So not all the sunshine that shines on the earth is turned into sugars by plants, because some of it just shines on our rocketers to heat. There's more sunlight than there is energy captured. And there's more plant material, biomass, than is eaten by the insects, right? And so you have what's called the energy pyramid, or it's also called the food pyramid. So now it's often called the trophic pyramid or the energy pyramid. Either word is fine. But this pyramid shape, then, what it's showing is that you have more stuff down here at this level than there is at this level. And then you got to have more primary consumers than you have secondary consumers. And you got to have more secondary consumers than you have top predators, because each level feeds off of the level beneath it. And that energy is being used up at that level too, right? So there's sometimes what is called a 10-to-1 rule, or a 10% rule. So the food chain pyramid here, I like this diagram. Now this one I wanted to show you too, how it kind of shows decomposers on the bottom. Decomposers are super important, and I hate to leave them out. But if you're talking about the flow of energy, decomposers recycle the energy. They don't recycle the energy, sorry. They recycle the material stuff, the nutrients, like the phosphorus and the nitrogen and the calcium and stuff like that. The energy comes from the sun and flows up the pyramid. So technically it should start from the producers on the bottom. Okay, so what I was getting to, though, is you have this 10% rule. Yes, if it's white, you got it right. So go ahead and write this down. 10% rule, each trophic level can only support 10% size level above it. So thinking now this picture, what it is here, it's like, say this is wheat or something like that. Grass is growing in the plains of Africa, and you have carbon dioxide and H2O. Those are the material stuff composing the biomass that it turns into, and also some micronutrients coming from the ground, like nitrogen, phosphorus, potassium are the main ones, but also calcium and a few others. And then the zebras eat that. Well, there's going to be, for every 1,000 kilograms of grass in the plains, that can sustain at most, and this is a rough number. It's just a guideline, right? It isn't exactly that, but it's, for our purposes, it works fine. Only 10% of that can go up to the next level. And so if you picture this thing carting up 10% to become the zebra, right? And so the biomass of the zebras, that's how much the living stuff weighs. You can only have about 100 kilograms of zebra for every 1,000 kilograms of grass. Okay, now you have the next predator up here, the lion hunting the zebras. Now, you can't have a pride of 500 lions trying to survive off of a herd of 500 zebras. That won't work. Pretty soon, the lions would wipe out all the zebras. Then all the lions are going to die off because they got nothing to eat. You have to have smaller numbers of predators at each level above it in order to have a big enough resource base to be able to support that population. So for every 100 kilograms of zebra, you can only have about 10 kilograms of lion. Like I said, the 10% rule, okay? And so they're also, the carbon dioxide and H2O are being exhaled. Those are, and they got the poop in there. That's always returning to the soil and then returning the nutrients to the plants and stuff like that. Okay, so then we get to the food pyramid here. This is one I'm going to have you have some questions about here. This is a marine biome. I just want to mention a couple things. I shouldn't use the word biome in this case. Let's just say ecosystem. And a biome is a big area on the earth of a particular kind of ecosystem, like desert or plains or whatever. But the ecosystem here, food pyramid, they're using that terminology. So for every 10,000 pounds of phytoplankton, you can have about 1,000 pounds of krill and other zooplankton. Krill is a kind of a shrimp, right? And so these guys are feeding off of that guy. So the pyramid, it's a smaller wedge, right? Now up above that, the second order consumers or secondary consumers, you can have 100 pounds of small fish feeding off of the 1,000 pounds of krill. Now here's something worth mentioning. If you're talking about the baleen whales, they don't eat like higher up. They just go right to this mess. You got a lot more food down here. So when you go to, I don't know, let's say the humpback whales in Alaska during the summer when they go to feed, they have these amazing techniques they use to scoop up giant mouthfuls of krill, which are like this kind of a shrimp, because there's more things at this level to survive, to feed on, than there are up here. So actually, that's a pretty effective strategy. That's why some of the biggest things in the world eat the small organisms instead of other bigger organisms. Okay, but anyway, you have this small fish and stuff like that. And then the third order would be the salmon, right? You can have 10 pounds of salmon for 100 pounds of small fish. Of course, the salmon aren't eating the whale, so it isn't everything on this level gets eaten by these guys. But the salmon eat herring and stuff like that, smaller fish, right? Okay, and then you could have the orca, the killer whales, up here eating the salmon. Or you actually, sometimes now, it's the resident killer whales, the resident orcas that live in, sometimes in Puget Sound, but usually up around Canada in there, just a little north of us. And then in the summer they come down. They eat mostly salmon, right? Our local community, resident orcas. The transient ones that travel around up the coast of California and stuff, they eat mostly marine mammals. So there might be a whole other layer here of marine mammals for the transient killer whale populations. So anyway, the point is you have only, for every 10,000 pounds of phytoplankton, you can have 1,000 pounds of fish. For 100 pounds of small fish, you can have 10 pounds of salmon. For every 10 pounds of salmon, 1 pound of killer whale. That means for every 10,000 pounds of phytoplankton to support 1 pound of killer whale. Okay, that's what this means. You got to have a solid foundation of producers to support the consumers above. And every layer up, you got fewer and fewer members in that community.